This is section 2.6, part 2, where we are going to describe and estimate correlation coefficients. So we're going to take our knowledge of correlation. We know that there's positive correlation, negative correlation, and approximately no correlation. And we are going to take it one step further and apply a number to each correlation. All right, and that number is represented by our correlation coefficient. All right, and so we got a little number line here, and notice that there's an R over on the left side. Our correlation coefficients are going to be represented by the letter R. And correlation coefficients can actually be any number between -1 and 1. Any number. We're going to simplify things though, and we're just going to give our correlation coefficient one of 5 values. So it's either going to be -1, -0.5, 0, 0.5, and 1. All right, so we're only going to deal with 5 values between -1 and 1. So if there is strong negative correlation, essentially a set of data points decreasing because it's negative, and they're very, very close together, quite tight, and they look like they could be a straight line or are very close to a straight line, we're going to give the correlation coefficient a -1. If we can tell that the negative correlation exists, all right, but the data points aren't very close together, they're not super tight, but we can still see the negative trend, we're going to give it a correlation coefficient of R equals -0.5. If when we look at a scatter plot and we have no idea if it's positive or negative, the data points are just everywhere, it's very random, we're going to assume or know that there's approximately no correlation, so our correlation coefficient will be R equals 0. And then if we can tell that there's a positive correlation, but the data points aren't very close together, but there's still a trend, a positive trend, we're going to give it a 0.5, R equals 0.5 value. And then lastly, if we can tell the positive correlation and the points are quite close together, they're quite tight, we'll give it a correlation coefficient of R equals 1. So we're going to look at 3 different examples so you can actually have a visual representation. And as always, make sure you're copying this down and getting it in your notes. So here's the first one. All right, and we can see we've got our XY coordinate plane, and a scatter plot doesn't have to be extending, it doesn't have to extend through all quadrants, all 4 quadrants of through the XY coordinate plane. It could just exist in one, and those are the examples that you're going to see here. All right, we're just in one quadrant, and we see that a negative correlation does exist because these data points are definitely falling from left to right, and they're pretty compact. They're pretty close together. All right, it's not a perfect straight line, but that's okay. They're pretty darn close. So we are going to say that this is strong negative correlation. All right, I'm going to write this down. Strong negative correlation. And I'm going to assign the correlation coefficient that goes along with strong negative correlation, which is R equals -1. Let's look at a second one. Here, I've got my XY coordinate plane, a bunch of data points plotted, and to me, it looks like there is a positive correlation. These data points are increasing from left to right, but if you compare to problem 1, they're definitely not as tight. All right, they don't form a straight line, and they're not that close to forming a straight line. So rather than saying strong positive correlation, I'm going to say it's weak positive correlation, and that's going to have a correlation coefficient value of R equals 0.5. So for number 2, we have weak positive correlation. And our R value, our correlation coefficient, is positive 0.5. Let's go down to the third and final problem. All right, we've got our xy coordinate plane. Data points are plotted. And looking at this, I don't really see a correlation. It's really tough to tell if it's increasing or decreasing because the data points are so spread out. So I'm going to say it's approximately no correlation. And I'll scroll back up to our number line. And we can see approximately no correlation has a correlation coefficient value of r equals 0. Alright, so that'll be the last part I write down here. R equals 0. Okay, so we've described and estimated correlation coefficients.